All right, welcome to the video to review for your test tomorrow. So I'm not going to go through all of the questions that are in your review packet because you have the answer key already. I am, however, going to go through the two proof questions because I feel like that's what a lot of us are looking at. So first things first for this first proof is it is a CP/CTC proof. I know that right away because it's asking us to prove that there is two congruent segments. That's usually going to be the case for CP/CTC proofs. So I have to first figure out what triangles I want to prove are congruent. So I'm going to highlight the two things I want to try and prove, and then a triangle that it's in. So I'm going to start by highlighting EH and then say, all right, well, that's in that triangle. Those two triangles look like they're the same size, so that's probably the two that I'm going to prove are congruent. Then if I start looking through what I know about the shape, so it's a parallelogram, so I know opposite sides are congruent. So that's one set of sides, so that's a good thing. So I can put that in my proof. So I'm going to put parallelogram, DEFG, that's given. Now, one of the things some of you did on the take-home quiz is you just said that the sides were congruent. You didn't tell me why, or you just said because opposite sides are congruent. You have to tell me in a parallelogram opposite sides are congruent. So the correct statement for this would be that DG is congruent to EF because in a parallelogram, opposite sides are congruent. So now I have one of the three pieces of info that I need. The other thing I know about a parallelogram is the opposite angles are congruent. So angle D and angle F are congruent, but I'm going to call angle F angle 2. And then because it's a parallelogram, I know I have parallel sides. Therefore, these two angles are alternate interior, so I'll say that's angle 3. So 1, 2, and 3 are all the same size. So because it's a parallelogram, I can say angle 1 is congruent to angle 2 because in a parallelogram, opposite angles are congruent. Also, because this is a parallelogram, I can say that GF is parallel to DE because in a parallelogram, opposite sides are parallel. And then I can say angles 2 and 3 are congruent because of alternate interior angles. And then I have angles 1 and 2 are the same, and angles 2 and 3 are the same. So off of all of this, I could say that angles 1 and 3 are the same by substitution. So now I have a set of sides and I have a set of angles. Let's keep going with this proof. So it also gives me this piece of information, which is nice. DGK is congruent to EFH. That gives us an angle-side-angle relationship. So now I have that in my proof. So I could say angle DGK is congruent to angle EFH. That's given. Well, now I have angle-side-angle, so then I can say that those two triangles are congruent. So I could say triangle DGK is congruent to triangle EFH by angle-side-angle. And then I could say DK and EH are congruent. By CP/CTC. Not too bad. The next one that I had you do as a proof was this one. This one's actually easier. It asks us to prove that AED is congruent to CEB. We actually did this one in class. So because ABCD is a parallelogram, I know two major things that help us here. I know that the diagonals bisect each other. So I know that AE is equal to EC. And I know that DE is equal to BE. And I can say in a parallelogram, diagonals bisect each other. And I also know that AD is congruent to BC because in a parallelogram, opposite sides are congruent. Wow, I spelled parallelogram wrong. Let me fix that. We don't want that. So then I know that these two triangles are congruent by side, side, side. Now you could have used vertical angles here. You could have used the fact that the sides are parallel and did alternate interior, but I thought side, side, side was pretty easy. So then we can do triangle AED. It's congruent to triangle CEB. And we could say it's by side, side, side. There's your proof, all done for you. Now the next part says describe a rigid motion that maps the triangles onto each other. Now this is not a reflection, it's a rotation. So I'm going to say I'm going to rotate about point E 180 degrees. That part's important if it asks you to that. I'm not going to ask you about rigid motions though on tomorrow's test. Hopefully this video helped you understand or at least be a little bit more comfortable with the proofs. Remember, tomorrow's test does not have a ton of proofs on it, so don't freak out. Hopefully you're all studying and watching these videos. Have a good night.